I'm in the process, hopefully, of switching the accessory management on my layout from CMRI to MQTT, and at the same time switch from the RS485 communication wires to Ethernet and potentially Wi-Fi as well. I've done one video already on the basics, getting Ethernet connected and getting the MQTT connectivity set up, and in that video I did some work on turnouts as well and getting servos to react to instructions sent from JMRI. Next is sensors, and particularly because I'm moving from CMRI to MQTT, sensors are going to be a little bit more in depth than I'm used to. There are quite a lot of sensors dotted around this layout and of different types as well. These are current detecting block detectors. There are micro switches attached to the servo turnout mounts, and there are also quite a lot of infrared sensors, especially over the other side under the storage lines. As far as sensors were concerned, CMRI was always really quite kind, in a sense, in that a lot of the hard work with sensors was taken out of the equation, both by the CMRI attachment on JMRI and the Arduino CMRI library written by Michael Adams that most people who use Arduinos and CMRI probably run. And the hard work was taken away because 4 times a second by default, this JMRI CMRI software on wherever JMRI is running will send out what's called a poll to all of the nodes connected to the RS485 bus. And the Arduino CMRI software is programmed to, when it receives a poll, respond with the current state of all of the inputs on that Arduino. So all the user had to take care of effectively in writing the Arduino script was to, every time the loop ran, read the status of all of the pins and then update them using that CMRI.getBit or getByte in the data array that CMRI manages, and then when CMRI responds to a poll every 4 times a second, it just takes the current state of those arrays of data and posts them back to JMRI. From the point of view of someone managing the Arduino sketch and managing a CMRI layout, then what that meant was I didn't have to worry about managing the state of sensors and detecting whether the state of them had changed or not, because I knew that 4 times a second the state of them would be sent to JMRI anyway. MQTT is not like that. JMRI, you set up MQTT in JMRI, and then JMRI just sits there and says, okay, thanks, yeah, I'm going to sit here, I'm going to listen, and you can send me updates on these sensors whenever you like, but I'm not going to ask you for it. What that means for me is, in writing a sketch or rewriting my current sketches to work with MQTT instead of CMRI, I need to be much more aware of my sensors. I need to know what their current state is, and then I need to, every time the loop goes through, I need to check if they have a new state, and if they do have a new state, that means that their state has changed, and that's the point when I need to voluntarily send the state of that sensor up to JMRI. I do like that, it's much more efficient. There was obviously a lot of needless data being sent 4 times a second in response to those polls, because it was a state of every sensor is being sent from the Arduino through RS485 into CMRI 4 times a second, which, okay, they're only noughts and ones, it's only maybe 4 or 5 bytes of data, but it still seems excessive. And that probably could be done with MQTT. You could probably write a sketch that just analyzes the state of the sensors 4 times a second or whatever, and sends publish messages to MQTT, but that seems inefficient. Sorry. So what I'm going to try and do is create something that will manage the state of the sensors and only send updates through MQTT to JMRI as and when sensor states change. So having resigned myself to the fact that I'm going to have to work harder on sensors with MQTT than I did on CMRI. I need to start thinking about how I'm going to manage them. And first thing to think about is what information I actually need to store about them. Now, I could, that may be the first thing, because I'm lazy stroke efficient. The first thing I thought about, well, why don't I just create an array of integers or booleans and store the last known value of each sensor in there, and the index of the item in the array will match its pin number. But there's immediately problems with that because I can't use all of the pins on the Arduino. Excuse me. Pin 0 and 1 are to do with serial, pin 13 is the LED pin, so I would soon end up with a mismatch between array indexes and values, and I think once you get to the point where you realise you've got to manage that, maybe there are better ways to do it. And the way I'm going to try and do it is with a class. So the first thing I need to think about in my class is what information do I need to store about a sensor. Well, first of all, I need to know its last known value. I need to know its current status value if I'm going to check it against what any new status it might be to see if it's changed. Might be a good idea to know its pin number, a descriptive name that will help me identify it in the code as much as anything else. Whether it's inverted, some sensors report 0 when they're active and 1 when they're inactive. Also, it's pin mode, whether it's input or input pull up, and I'll come on to that later. A couple of other things I need to know. I'm going to need to know its JMRI ID 1001, 1002, whatever, because I know that the way MQTT works is I'm going to have to update it with a topic including its JMRI ID, so I'm going to need to know that. And I'm also going to keep a string value of its state, whether that's active or inactive, again because they're the values that JMRI is expecting when I send updates through MQTT. So once I've collected that information about each sensor, the next question is, well, what am I going to want to do with that information? And there's three main things I think I'm going to need to do. First of all, update the sensor. Check to see if its state is different now to the state that I thought it was, or that I had tracked. Set its pin mode, because if we know its pin mode, we might as well use it to go through and set all the pins that represent the sensors to input pull up. And also this one, get a sensor publish topic, because, well, we'll come to that anyway. So these are the three things that we need to do. So here are the methods that do those things. First one is update the sensor. So we'll get its value. We know its pin because this is dealing with this particular sensor. So we know its pin number. Let's get its value from that pin. And if its value is equal to the last known value, we're going to return false. This method returns a Boolean, which is true or false. And the reason why it returns true or false is that lets the code that was calling it know whether the state had changed. So when you call this update sensor, it does a few things. It records the value, but also it says if it detects that the sensor status didn't change, it will just return a false, so that the code knows nothing's changed. Happy, I don't need to send an update to MQTT. However, if it detects that there was a change, then it stores the new value as the last known value. It sets the active and inactive string values so that the code finds it easier to send the MQTT update, and then it returns a true to say, yep, this sensor value has changed since we last knew about it, so you do need to send an update to MQTT. And then a couple of other things. Set its pin mode. Pin mode, it would be when it's set would be input pull up or input. And also here, just again to make life easier for the code, return a string that will tell the code when it's called exactly what the topic is that it needs to send to JMRI. Having created my class, then I've effectively created a template from which I can create objects that hold that information. And to include my class, there's just a little include line up at the top. So there's a few others there as well. But this is where I create my array of sensors. an object-oriented language like C++ allows objects to be created within objects, or objects to be related to each other. So where I might be more familiar with creating an array of integers are very simple objects, but they're still objects, or booleans or strings, that kind of thing. I can also create an array of objects. So here I've set my number of sensors up here. I think at the minute I just have one because I'm just testing, but I've created an array of sensors. So this is a list of those sensor objects, and each object within that array will hold all that information about the sensor. So the good news from this point of view is, although I still have a zero index list, and those the index numbers of each sensor within the list won't match pin numbers, I have information within each object in the list that tells me what pin number the sensor that's in that object in the list is on. When I declare that array of sensor objects, C++ right at the start of the sketch actually creates that array, and it populates it with lots of objects that represent these sensors, the same number obviously that I declared, in this case 1, but it's going to end up being 30 or whatever it is, and it creates them with all of these default values that are declared in the class definition. So every single, say I've got 30 sensors in there, every single sensor is going to be created with no name, an input pin of -1, no JMRI ID, it's going to be set to not inverted, it's going to have a pin mode of input, and its last known value is going to be 0. And for every single sensor, most of that information is wrong. So I've now got the somewhat laborious task of actually populating that information. Again, this isn't stuff I had to do particularly in the CMRI script, but I do think it's going to be useful to have all that information together in this sketch, partly for my own use to know what's on each pin, but also because much of it is going to be needed anyway for setting pins, and for reading pins, and for knowing whether a sensor is inverted, and for knowing its JMRI ID so that I can update its status in JMRI. So I'm going to have to go to a few different places to collect that information up. A good starting place will be the sensors table. Now this is, I'm working, of course there's no real concept of nodes either in MQTT, but I'm at the minute I have 3 Arduinos, so I might as well keep referring them to them as nodes. And the sketch I'm currently writing will probably be for node 1, so they'll start at 1001. So then I start looking at these sensors, and here are there's 2 useful bits of information here really if I'm going to start producing a corresponding sensor table in my sketch. I've got their IDs, which are just the numeric values here, 1001, 1002. I've got their username, and I've also got, for a lot of them, whether they're inverted. I've always been lazy and inverted them in JMRI, but I might take the opportunity to set the inversion as soon as the pin's red, and so that all these buttons are unticked, but I'll cross that bridge when I come to it. So this is the first area where I'm going to get useful information from, and the second one is going to be the old CMRI based script. So if I load one of those in, let's try this one. Down at the bottom somewhere there'll be where I was setting all my pin modes. So there wasn't much information in here really, but here are the pin modes that are on the various pins, and there'll also be somewhere, I can't, here we go, where I actually set the bits, and I put some comments in. So this again, this illustrates how useful it would be to have all this information in one list, nicely listed out where everything's linked up, because here I've kind of got to go through code comments where I added them. I've got to map which CMRI bit it was setting to which pin that it read, and then up here I've got where whether they were input or input pull up. So it's going to take me a little while now to pull that information together and put it in a nice set of tables in my new script. And just while I'm working my way through this, doing this incredibly boring stuff, a fairly useful tip: if you right click on anything in JMRI, you can copy the username and then just go and paste it in there. So that's a quicker way of getting the descriptive names in. These aren't needed, these descriptive names. It'll get by without them. It's just helping me, when I look at this sensor table, see exactly which sensor I'm talking about, which user ID it's on. It just keeps everything in one place. The vast majority of the data is needed, but the name in particular isn't actually critical. Here we go then. I've been through and painstakingly created a list of all sensors that are directly attached to this Arduino. And now I have this list, what am I going to do with it in the code? Well, this is effectively a setup function. It's called from the setup part of the sketch. So we've now set up our sensors. The first thing to do, it'd be a good idea to set the pin mode on them. So go through every sensor in the list. The sensor, and each sensor object contains what the pin mode is, so just set it. And then secondly, we'll update the sensor. So for each sensor going down here, we're running set pin mode, so we're setting the pin mode on that pin according to how it's been specified. And we're also updating the sensor because that's going to put the last known value in the last known value field. So once we get to the end of this little loop, we have a list of sensors. They all have their pin mode set, and they all have the correct value in their last known red state. I think there's an argument here. This function is going to be returning a bool anyway as to whether the sensor was updated, and because it kind of has been updated because we've just turned the thing on. But this loop here, this call to update sensor, is run just as we turn the Arduino on. So I think there is an argument here to send a message through MQTT with the state of the turnout, so that when if the Arduino is turned on before JMRI starts, the Arduino is already queued up through MQTT a load of messages telling JMRI as soon as it starts up what the state of all these sensors is. There is a setting when publishing a message to an MQTT server for it to retain that message. And what that means is, if I just by default send a publish message to an MQTT server, all objects or systems, whatever they are, that are currently subscribed to that topic will receive a message with that update. But if they're not actively connected and listening at that point in time, they'll miss it and they'll never receive it. So if we take JMRI just starting up as an example, if I was to send the 22 publish messages from these 22 sensors to MQTT as this Arduino starts up without the retain flag, and JMRI hasn't started up yet, there's no point in sending those 22 messages because JMRI wasn't started up. It didn't get the message and those messages, and they just got lost in the ether. But if I send them with a retain flag, then they'll sit on the server and JMRI will read them when it starts up. I think there's a way of thinking that says, well, it certainly in this model railway scenario, all messages should have a retain going in both directions, just in case they got missed, because anything that does miss a message is going to want to know what that message is as soon as it reconnects. I think that's the way that JMRI works too. So anyway, we've got through setup, we've set up our sensor table, we have gone through, we've set the pin modes, and we've given them the last known value, and very probably here I will add something that sends a message for all 22 sensors to the MQTT broker to queue up their state for JMRI to pick up when it starts up. So then JMRI starts up and we get into the normal operating loop of the sketch, which I think and hope is up here somewhere. So ignore the shift register stuff for now, and this is just reconnecting to MQTT if we lose the connection. And all we have to do here at this point is call a function called update sensor. So we do again a loop for every sensor that we're aware of, call a
function called update sensor, and that is confusingly does have the same name as the function on the class, but never mind. That is down here somewhere. Here's update sensor. So here's our bool. So we're saying, because we're passed in the index, because we were in a for loop, we're passed in the index of the sensor we want to look at. So look at that particular sensor in the list and run the update sensor. So this will check the pin, it will update the last known value, it will update the state if it needs to, and it will return this boolean has changed to tell this part of the sketch whether that sensor value has changed since the last time we checked. And if it has, this is where we then put the publish message together. The MQTT library expects a char array, so there's a little bit to do there, but eventually all we do really is just publish that new message using the various bits of information that we created functions to return on the class, and then just send the publish update to the MQTT broker for JMRI to pick up. I think it's time to give sensors a test then. And in order to test it, I've commented out the great big sensor table because I can only really test that extensively once it's up in the loft. But I do have one sensor set up in this sketch here, and I have one sensor here attached to a test Arduino that will run the script. So I'm gonna set this uploading and kind of try and watch the data as it goes all the way through the MQTT and then the process into JMRI. So that's uploaded. I'm going to open up a monitor which has naturally started up on another. So that's an interesting start. It's I can't quite remember which bit of the comments it's reported that out, but we have a connection to MQTT, which is the important bit. I've also got a command line running that will subscribe to that sensor topic, because I know that sensor topic is the one that JMRI is going to listen on. So let's get Panel Pro open as well. And my little MQTT test profile. There it is. So the important things here, if I go to preferences, I know JMRI does tell me in the MQTT additional settings that it is listening. Its received topic is track sensor, and then I assume, I think there is documentation that I did dig out that you need the ID after that, 1001, 1002, and the messages you send in capital letters are active and inactive, and I think that was documented somewhere, and it was kind of relatively intuitive and easy to guess as well. So if I load my settings in, I think I do have a sensor set up. I do, and it's probably a good sign that it's already saying inactive. I can move Panel Pro out of the way. So now if I just grab a sensor, and I think it's got a light on the back, so I'll know, hopefully the camera will pick up when it's lit. But I think everything is behaving as it should. I've got the COM13 window, is it? That's displaying the serial debug output, and I can see that that's detecting when a sensor's changed. I've got the black window as a subscription to that sensor feed on the MQTT server, and I can see that is moving when it should. And then the bottom window, of course, is the sensors table in JMRI, and that is responding instantly as well. So it looks to me like I might have sensors working too. Except, of course, that while the light's on, it's set to inactive. So that's, again, that is down to, if I go back into the text, I might as well do this, fully test it. That's because those IR sensors do report the opposite. So they give a 0 when they're active and a 1 when they're not. So what I should be able to do is switch this from a true to a false, because this is the invert sensor. I haven't tested this. This will be a good test. Upload the sketch again. JMRI and everything can just stay on because it's actually looking at the MQTT server, not this Arduino, so it's not ever going to know that it's lost a connection. So we're connected back up to the server again. Let's get this back up and see if we're now working the opposite way around and on the sensors table up as well. So it's now saying it's inactive, which does appear to be wrong. Let's see what. Right, yeah, it's updated itself now. It's now inactive. And if I put my finger on there, we're now working the opposite way around. So it is, the sketch is now reporting the opposite of what it sees from the pin, which to everything else appears to be the right way around.
Encouraging again then, and I'm pretty confident now that I can work with sensors that are directly attached to the Arduino through MQTT, and that maybe with a bit of tweaking on startup they'll work as I'd like them to. There are, however, a couple more groups of inputs and outputs that the Arduinos work with, on my layout at least, that haven't been catered for so far, and that is shift registers. There's one just over there, and I think there's one down here somewhere as well. There it is. I have a number of shift registers attached to both of or all of the Arduinos, and in CMRI, again going back to that, shift registers were so easy to deal with because they just return a byte, and CMRI works in bytes. It was very easy to receive or receive a byte from either CMRI that would go out to the shift registers, or receive a byte from the shift registers that would go out to CMRI. But no such luck with MQTT. MQTT deals purely with individual updates for individual sensors or outputs. So there's going to be a bit more work involved in getting shift registers working. And I think this sensor stuff has masked my brain enough for now, so shift registers perhaps get left for another day.